Welcome back, everybody. This is Mr. Navarrete, and today I'll be going over heat problems number one. So, with that in mind, let's get started. For number one, it asks how much heat would be required to increase the temperature of 50.0 grams of water from 23.5 degrees Celsius to 30 degrees Celsius. So, just annotating the question, we want to find heat. We are also given our mass, the 50.0 grams. And we want to go from 23.5 degrees Celsius, so that's T initial, to 30.0 degrees Celsius, which is going to be my final temperature. With that, we can use our heat equation, which lets us know that heat is going to be equal to our mass times our specific heat times our change in temperature. Since we already have everything annotated, we can just plug those numbers in. My mass of 50.0 grams. Looking at my table, it lets me know that my specific heat for water is 4.18 joules over grams times degrees Kelvin. And my change in temperature, well, we know my final is 30.0 degrees Celsius, and my initial is 23.5 degrees Celsius. Yes, our units for temperature, one is in Celsius, and for specific heat, it's in Kelvin. But remember that our change in degrees Celsius and our change in degree Kelvin is going to be the same. So if we make the conversion, we'd end up with the same change in temperature. Plugging those numbers in, I get my heat to be 1,360 joules. For 2, we're being asked to recalculate heat from number 1, but instead of using our specific heat in joules, we're going to be using calories. And it lets us know that the specific heat of water is going to be 1 calorie per gram times degree Kelvin. So using that relationship again for heat, well, we already know that our mass is going to be 50.0 grams. Our specific heat of water in calories is 1.00 calories per gram per degree Kelvin. And we still are going to have that same change in temperature. Plugging those numbers in, I get a heat of 325 calories. 3 asks how much heat would be required to increase the temperature of 25.0 grams of gold from 23.5 degrees Celsius to 37.5 degrees Celsius. So annotating it again, we want to find heat. We are given our mass of 25.0 grams from 23.5 degrees Celsius, that's going to be T initial, and to 37.5 degrees Celsius, that's going to be my T final. So same relationship, heat is going to be equal to mass times specific heat times delta T. And plugging our numbers in, the 25.0 grams, that's going to be my mass. The table that is given in the top of the handout lets me know that my specific heat for gold is 0.130 joules per gram times degree Kelvin. And my change in temperature, will T final minus T initial. Plugging those numbers into my calculator, I get a heat of 45.5 joules. 4 asks how much heat is required to increase the temperature of 143 grams of silver by 26.5 degrees Celsius. So again, annotating it, we want to find heat. We want to know how much. We are given our mass, 143 grams of silver, but instead of being told initial and final temperature, we are just told the change in that temperature. So heat is equal to our mass times specific heat times our change in temperature. So our mass is 143 grams. Looking at my table lets me know my specific heat for silver. And we already know our change in temperature of 26.5 degrees Celsius. So plugging those numbers into my calculator, I get 891 joules. 5 asks, how much heat is removed when the temperature of 823 grams of copper goes from 63.6 degrees Celsius to 50.0 degrees Celsius? Annotating it, 823 grams, that's going to be my mass. 63.6 degrees Celsius, that's going to be my T initial since it says from. And to 50.0 degrees Celsius, well, that's going to be T final. So using my relationship, heat is equal to mass times specific heat times change in temperature. Plugging those numbers in, we know our mass. My table lets me know my specific heat. And now my change in temperature, T final minus T initial. Plugging those numbers in, it says that my heat is going to be negative 4,250 joules. Now, why the negative? Well, remember, the question asks how much heat is removed. So it's going to be losing an amount of heat. That's what the sign tells us, whether it's going to be gaining or losing heat. 6 asks, a chunk of iron increases in temperature by 36.5 degrees Celsius. If the heat added was 18,689 joules, what was the mass of the chunk of iron? So we're still going to be using that same relationship, but now we are told different things. We are given our heat, we are given our change in temperature, our table lets us know our specific heat. We want to find our mass. So just using some algebra, I'm going to get the mass by itself. So dividing both sides by specific heat times change in temperature. It'll cancel on this side. I am left with my mass is going to be equal to heat added divided by the specific heat times that change in temperature. Plugging the numbers in, we know our heat is 18,689 joules. Table lets me know my specific heat, and our change in temperature is 35.6 degrees Celsius. Plugging those numbers into my calculator, I get a mass of 1,120 grams, or we can change it to kilograms and keep it as 1.12 kilograms. 7 as a piece of aluminum was cooled from 37.0 degrees Celsius to 22.5 degrees Celsius. The heat change was determined to be negative 1.199 joules. What was the mass of the aluminum? So very similar problem to the one before. We are told our changes in temperature. So we go from 37.0 degrees Celsius. So that's going to be my T initial. 22.5 degrees Celsius. That's going to be T final. And we are told that the change in heat was negative 1.199 joules. What we need to find out is the mass. So with our relationship for heat, doing some algebra, we can get our mass is going to be equal to our heat divided by specific heat times our change in temperature. Adding the values that we annotated and plugging those into our calculator, we get a mass of 0.0911 grams. 8 asks, a diamond was heated accidentally. The heat for the process was positive 11.13 joules. If the mass of the diamond was 3.14 grams, calculate the temperature change in of the diamond. So annotating to see what we got. Well, that's going to be my heat. We know our mass. My table lets me know my specific heat for our diamond. The question wants to know the change in temperature. So that just means that we're going to have to use some algebra with our heat relationship. So if heat is equal to my mass times specific heat times my change in temperature, if I need to get my temperature by itself, I can divide both sides by mass and specific heat. Mass will cancel. Specific heat will cancel on this side. So I get that my change in temperature is going to be equal to heat divided by mass times my specific heat. Adding the values that we annotated and plugging those into our calculator, we get a change of temperature of 7.61 degrees. 9 asks, a silver coin at 22.5 degrees Celsius was heated for 22.5 minutes. The heat added was determined to be 222 joules. What was the final temperature of the coin if its mass was 22.2 grams? So let's look at what info we were given. We were told that it was heated at 22.5 degrees Celsius. So that's going to be my initial temperature. We were told that the heat added was 222 joules. So that's going to be heat. We are told that the mass of the coin was 22.2 grams. And we need to find our final temperature. So looking at my relationship, heat is going to be equal to my mass times specific heat times my change in temperature. But what about the 22.5 minutes? Well, it's not mentioned anywhere in my relationship, so then I don't need that time. It's just extra info. So since I need to find final temperature, I'm going to rearrange it to get delta T by itself. So with some algebra, I can get delta T is equal to my heat divided by mass times specific heat. We know that change in temperature is our final temperature minus our initial. So then I can separate that into T final minus T initial is equal to heat divided by mass times specific heat. And I would add T initial to both sides. That way these cancel. And I just have to say that my final temperature is going to be equal to initial plus my heat divided by my mass times specific heat. Now that I know what my final temperature should equal, I can plug in the values that I have. I know my initial temperature, I know the heat, I know my mass, and my table lets me know my specific heat for my silver coin. Plugging those numbers into my calculator, I get a final temperature of 65.1 degrees Celsius. Last but not least, we have number 10 that says a piece of wood was found to be 77.4 degrees Celsius after it was heated for 36 minutes. The mass of the wood was 156.7 grams and the heat was 489.6 joules. What was the initial temperature of the wood before it was heated? So annotating to see what we were given, we are told that 77.4 degrees Celsius, it was after. So then that's going to be my final temperature. We are told the mass of the wood. We are told the heat that it was added. We want to find initial temperature. So I'm going to solve this one just a little bit differently. So I'm still going to be using my relationship for heat. Since we don't know our change in temperatures, we know final but not initial. I'm going to solve for that change. So using some algebra, I can get that my change in temperature is going to be equal to my heat divided by mass times specific heat. We know how much heat was added. We know our mass, and my table lets me know my specific heat. So plugging those numbers in, I get a change of temperature of 1.775 degrees. So now I know that my change in temperature, which is equal to my final temperature minus my initial, has to equal 1.775 degrees. Well, we already know our final temperature. We can find our initial, but whatever that subtraction is, it has to be equal to 1.775 degrees. So get T initial by itself. So subtract 77.4 from both sides. I get negative T initial is equal to negative 75.6. Dividing by a negative, I get my initial temperature to be 75.6 degrees. And that's it. If you have any questions, feel free to reach out. But other than that, stay safe, and I'll catch y'all next time.